last year I had the privilege of being here as well and speaking, and they had me up on the stage 4, the Blazor stage, as I like to call it, because that's where Steve Sanderson originally first introduced Blazor to the world, and I was excited about that. But I figured out, just like it is here today, there's big lights shining on you, so you can't really see anything besides your own screen there. So I took a few steps back on that stage, and then there was the big screen above me that sort of shielded me from the light. And I thought that was a good idea, that was more comfortable. But it turned out it wasn't the best idea I had, because when I went back to the hotel and just scrolled back to the video and just had a look just to see how bad I've done, what you could see in the video was a body and arms wailing about while I was articulating, but my head was completely gone. You couldn't see it. So I guess they stuck me down in this room where I have nowhere to hide. So let's see if we can get through this without me going blind. But I promise there's no light mode in this talk, so you should be fine. So we're going to talk about how to create maintainable and testable Blazor components. But before that, let me say hi. My name is Egil. I'm from Denmark originally, and I live in Iceland now. And if you want to reach out, you can reach out on Twitter and just add me. And if you have any questions now, or if you are watching this from the future, also feel free to just add me and ask your questions there. So, like I said, I'm Dane, but I live in Iceland, but I work remotely for a Danish company called Delegate, and we do primarily cloud-native solutions built on the Microsoft stack. So if you want to hear more about that, just reach out to me. I'm also a Microsoft MVP, and been that since 2020, and I became an MVP because I built bUnit, which is a testing library that we're going to talk a little bit about later today. And I also try to live stream on Twitch. So that's me programming and answering questions and having fun. So if you like what you see here today, and you might not, then feel free to jump in there. It's a good way to sort of engage and ask you questions and so. Yeah, that's the option you have. And but before we really get started, I want to sort of set the stage and align expectations. A lot of other people, maybe, I'm gonna agree, much smarter people than me have thought about what maintainability, how to make and how to create maintainable code. So I'm not really gonna reinvent any wheels here today. But what we will do, we will try to take those good ideas from all those people that have come before us and see how we can apply those ideas that we probably already apply to our regular C# code or Java or whatever you're coding in, and how we can apply those to Blazor as well. And that is sort of what we're going to focus on today. And one of those such people is Dan North. A couple of years ago, he formulated the qubit properties. And I really like those properties as well. They're great. But I think what really stood out to me was his decision to call them properties instead of principles. And this is the reasoning he gave. So he says, principles are like rules. You are either compliant or you're not, right? This gives rise to bounded sets of rule followers or rule enforcers rather than centered set of people with shared values. Instead, I started thinking about properties, qualities, or characteristics of code rather than rules to follow. So properties define a goal or center to move towards. Your code is only closer to or farther away from that center, and there's always a clear direction of travel. So this speaks to me because I don't always write, super clean, maintainable code, and I don't expect either of you to always do that. And sometimes hacking something together quickly is more valuable than spending a lot of time that it might take to write good maintainable code. I think sometimes, at least for me, it can take a bit longer to really, because you have to think deeper and harder sometimes about the code you're writing. So in that regard, I think it's nice that I can deliberately, I try to be deliberate about that, choose whether or not I want to go to what I would mean my definition of a good properties, go to that center, or if I choose to be deliberate about not staying there. And I bring this up because I also want to make it clear that I don't want you guys to go home and look at your Blazor components and say, oh man, Egil told me that this is how it's supposed to look and it doesn't look at all like that, and now, I don't want you to go home feeling bad. This is not what this is about. This is about us talking about discovering what good properties could be for Blazor components and have them as goals we can strive towards when we want to and when we need to, okay? So, maintainable components, I also find are testable components. And I'm sort of a person that don't really feel comfortable writing production code before I've written test code. So what do we mean by that? And that's sort of where I end up in that test-driven development camp. And I don't want to be a zealot about it. I don't want to say, well, this is always the best thing. But if you do, if you've considered trying to write code in a test-driven development fashion, you will probably experience that you also tend to write more maintainable code, because writing the test first sort of drives the design. And when you force yourself to write code, production code that you can actually test easily, which is generally what happens when you do write your test first, then you sort of land in that pit of success in terms of creating maintainable code. It doesn't have to be that way. You can certainly write your production code first, but I would suggest that you give it a try if you haven't tried test-driven development before. And don't be discouraged, because test-driven development takes 5 minutes to understand. Red, green, refactor, everybody can sort of process that and get that under their skin. But it takes quite a bit of practice to actually get good at it and see the advantages and feel that advantage. So keep it in your toolbox and take it out. But I will get back to testing later. But for now, let's talk about maintainability. And if we start at a high level, we have this fella here, Mark Seaman, who actually spoke about this exact topic a few hours ago. So if you didn't watch this talk on fractal architecture, you can go back in time and see it again. But if we start at the high level, Mark Seaman says in his book, Code That Fits in Your Head, he talks about maintainable code as something that follows a fractal architecture, or maintainable apps, maintainable code. And fractal architecture is sort of where we divide our application, our code, into layers in that fractal, and each layer has about up to seven things, concepts that it deals with. And if we want to sort of know more about the lower layers, well, we double-click on that fractal, and we get to a new fractal that contains another 7 concepts, but at a lower level. And that makes the code more easy to understand at the individual level. You can easier comprehend, and again, that leads to maintainability, I think. So as an added bonus, the whole metaphor of a fractal at different layers there translates very well to Blazor components, right? Because a Blazor component is typically a component that has subcomponents in it. So if we remember when we architect our Blazor applications in a way where we make sure that the subcomponents are sort of dealing with the same conceptual things, and then we go one layer deep, well, then we sort of can lean into that concept of fractal architecture. So I guess you've all seen, if you're Blazor developers, you've all seen that typically the entry point of a Blazor application is the app.razor file, right? And it has some infrastructure, it has the routing stuff, and then maybe has some other things like high-level concepts like cross-cutting concerns like authentication, stuff like that. Then you can double-click on one of those typical. That's going to be one body element there, and when you go into that, well, then you certainly have. So now you have the concept of maybe layout, where you have headers and navigation and center content, and if you can go into each of those, you can understand those in their own right without having that full up and down understanding of the full stack necessarily. So that's sort of the advantages of taking this approach, I think, and it applies very well to Blazor without us really having to force the issue. Now, if we go one step deeper and talk about, I'm going to use Dan's concept here of calling it properties, but properties of maintainable components. If we go down to the component level, these are sort of my go-to when I want to sort of start by building maintainable code. And this is sort of the same I do with just regular C# code for that matter, but the first thing is, and the one thing is that a component should be really good at doing that one thing. And I think the hardest part there is figuring out what is one thing. And are we 2 things, 3 things, 4 things? Are we just one thing? Are we good enough? So some of the other things we can go look for is whether or not the component is mixing abstraction levels. So we talked about the fractal before. Do we have multiple layers of a fractal within the same component or not? Another thing I tend to look at is whether or not a component exhibits high cohesion, or if it's the opposite, if it's sort of lower than that, low cohesion. And a fourth thing I want to, take in here today is going to be if I'm using abstractions in my components, or if I'm using stuff that are like infrastructure things directly in my code. So a typical thing you will see in a Blazor application could be using HTTP client directly in your component or a DB context, something like that. If you think about it, that's clearly a different abstraction level, different concept than putting stuff on screen for the user to interact with and work with. And it also quite hurts testability. It's going to make your test harder to write and work with. So do keep that in mind, okay? So let's make it a bit concrete. Let's create something that we can use to examine these properties with. And I have a dynamic data table component for you here. And it works by, imagine we have a page where we want to show movies on. So somehow we've gotten a collection of movies, a small list of movies, and what we need to do to make that print a pretty table for us is we need to pass that movies to our data table component, and it will figure out how to create a table with headers based on the public properties of our data item, in this case the movie, and it will print out a row for each movie with the data that was actually in that movie. So this is approximation. It's not, you can imagine that datetime would look a bit different when it's two strings, but the idea is sort of, this is the concept what we're building. So how does this look implementation-wise? Well, we need some magic, so of course we need system reflection in here. And what else? Well, we need a T item. So the T item represents the type of item we will be rendering out. And then we need a code block. And the first thing we need in our code block is going to be the parameter that can be used to pass in the items with. So that will receive the items from the outside. And then we need a little bit of helpers that can, help with the magic. And for this, we will use the reflection bit here, where we say the type of T item, and then we go and get the properties, and we say we only want the properties that are public and that are instance properties on our T item. And we also filter out those we cannot read. So give us all the properties that are instant and public and readable. So now that we know something about our T item, well, we can create another helper method that allows us to read the properties and create column names out of that, so we can print, the column header for the table. And finally, we need another helper method to actually get the data out of our individual items. So we have a get item data method that takes an item as input and uses the item property info collection we have there to select out the values. Now, if you scroll down a little bit, we obviously need a table to put it into, and then we need the table header. And in there we need a table row, and then we can for each over the result of the get column names method call and print out a table header cell for each of the public properties that exist in that component. And finally, we need also a T body, and we need to for each over each of the items. And when we have done that, we can use the get item data to pull out the data, and for each over each of the table cells, we need to print for each row. Now, it's a fairly simple component. And I can ask the question now, what can we do to make that even more simple and more maintainable for the future? And you might be sitting out here in the room in the future and watching this and thinking, well, it's like 30 lines, it's super simple already, and I wouldn't really disagree with you. But for the sake of demonstration, let's try anyway. And besides, we might have a product owner come and say, hey, that looks really super nice, but could we get some sorting? Could we get some filtering? Could we get some inline editing? And all of a sudden, our small, about 30 lines of component, sample component here grow and grew and grew, and now it's maybe not so easy to comprehend, easy to maintain anymore. So let's give it a go and see if we can refactor it a little bit and give ourselves a better chance of adding new features faster in the future. So if we address the first thing there and figure out, well, how can we refactor our component? Well, we could look at the idea about mixing abstraction levels. And so if we make this a bit concrete, we can see here the red parts here are really dealing with the plural multiple items, right? So that is sort of one level of abstraction you can look at from a data perspective. All of that code here that is highlighted in red, it's about the multiple of items. Whereas the green, not green, obviously, blue parts, they are about the individual item. You can sort of say that's an edge case around the column names, but let's, it's a different level of abstraction, I feel. So this is sort of an indication that's something we can do here to refactor this and split it up. Another thing we could look at is the cohesionness of our data table component. And cohesion was something it took me a while to sort of really grasp what that sort of fancy word meant. And in this case, it means that we can see that the red parts of the code, they don't really know or care or use anything from the blue parts. So these two parts of the code that are highlighted right now, they can exist in separate places without them really knowing anything about it. And so this is also an indication that the component here isn't really highly cohesive, because there's different parts of the component that use other parts, and then there's other parts again that use some other parts. So they could be grouped together and put to the side, and nothing would really, they wouldn't care that the other part is missing now. So let's try that refactoring. So I guess the first step would be to remove this items property info helper property we have here. And if we just pull that out into a separate class, because we're going to reuse that across different classes, well, our code looks like this now, and and I'm not cheating, so it's here now, and it looks like this. So this is the get items property info. It's a method now, but the same thing basically. And if we jump back here, well, the next step would be to pull out stuff related to the header, right? So let's do that and create a new component called, well, you guessed it, data table header. And it only really needs, in its current version, it only really needs to know what type of, what is the data type that is being rendered right now, because it just needs to have that type information so it can generate the right columns for the header. Now, next step, you probably already guessed this. Oh, well, sorry, I have to show you the new data table header component. As you can see, it's nice, concise. It's pretty clear. You can understand what's going on here right away, right? So, next step, as you would imagine, would be to pull out the thing that deals with printing out individual rows and create a data table row component. And again, this component will just take the item in as input. So our outer data table component will still iterate over each of the items, because it's dealing on that abstraction level, but we are passing down the individual items and the responsibility of rendering that to a lower level component. And this is going to be the data table row, which just deals with iterating over the individual fields in that item and printing out the table cells in a table row. Okay, so this is our final refactored data table component. And if we sort of take a step back and just go through those like the properties I was talking about before, and just double check. So I think the important takeaway really is the do one thing well kind of idea. And this is the same you should do for regular classes and methods, but I think it's easier to forget that with components sometimes. Perhaps it's because we have this mix of markup and code and logic together in one place. And it's quite easier to just add another block of markup into a component. But before you know it, you're scrolling up and down your rather long component, trying to find that little piece of markup that actually is responsible for that UI thing you want to change and fix, right? So remembering to apply that do one thing well, very known coding rule also to UI components, I think makes a difference. So and what we also get is, because we are utilizing the composability of Blazor components, and where we move related sections of markup and the code deriving them into sort of well-known subcomponents. You will also have shorter components that will be easier to understand. And again, we talked about the fractal concept with up to 7 things. And it's okay sort of to do this, even if subcomponent is only going to be used by a single parent component, I think. So yeah, we did glance over the don't depend on infrastructure here, but I think you can imagine if you, for example, had an HTTP client in here, for perhaps maybe to have some advanced feature where you can pass in a URL and have that URL point to a, I don't know, JSON document that you would download and print out as a table. Well, we would probably have to want to move that HTTP client out and have an abstraction representing that functionality of downloading code and returning maybe some sort of JSON document or object that you can reiterate over and spit out in the table. Let's go ahead and change gears a little bit and look at how we can use sort of our how easy it is to test well-factored Blazor components and isolate that and get fast and stable tests. So to do that, we can use bUnit, but I'll first tell you what bUnit is and why it is or why we need it. So bUnit is a library that we can use to test Blazor components. And I sort of want to underscore the word library here, because it's not a framework like XUnit or MS Test or NUnit. bUnit is a library that you add on top of those. You create a regular old XUnit or NUnit or MS test project, and when you have that, you can install all the normal tools you do, like Fluent Assertion maybe, or MOQ or InSubstitute, or whatever you use. And bUnit is just another library like those that enable you to test things, Blazor components in particular. That also means that bUnit tests, I call it bUnit test, but it's really just whatever test you're writing in that test framework. Those tests will look and feel kind of the same, and that's the goal of bUnit, is to make it feel familiar. If you have good patterns and practices you're following in your organization for writing tests, well, those tests that test Blazor components shouldn't feel different than that. So that's what bUnit enables us, and we can reuse those patterns and practices that we really we have established there, and also other libraries that we use in our test. Now, there is a thing that tends to surprise newcomers to bUnit, and maybe especially if they've used something like Selenium or Playwright before. And it is that bUnit doesn't run your JavaScript code. It actually doesn't run in a browser at all. It's completely just it's just C# code it will run. And that's both an advantage and disadvantage. Luckily, the Blazor team decided to create Blazor such that when you want to call JavaScript, you're actually calling through an abstraction through the IJS runtime interface, right? And that means that during a bUnit test, if you have interactions with JavaScript from your component to JavaScript, you can, there's a built-in JavaScript interrupt functionality in bUnit that allows you to set up and configure those expectations, how you want your JavaScript to behave. If that is not enough. And I think for the most part, that's at least the promise of Blazor, is that we don't have to write a lot of JavaScript. It's mostly just plumbing to get to some browser APIs. But if you have more complex interactions you want to test, obviously I do recommend creating real end-to-end tests where you use something like Playwright or maybe Telerik Test Studio and set up a test. And in those end-to-end tests, a headless browser will be started in the background, and it will load up a Blazor app and load up your component, and it will run the JavaScript, and you will be able to expect the outcome. But there is a disadvantage to that, and this is where bUnit shines, is that it runs basically as fast as your regular unit test. So it's much faster generally than it is to do those real end-to-end tests where you have to spin up a browser. And it also has the advantage that because bUnit is sort of working with the Blazor runtime, the real Blazor runtime, we can put some hooks into that, and we will know much more about what's going on with your components and where they are in the life cycle, and allow you to have more stable and predictable tests where you don't have to do a lot of, well, if you tried creating end-to-end tests before in the front end, you know that they can be a little bit unstable sometimes. So we don't really have necessarily that problem. And how do we go about using bUnit? Well, this is a standard XUnit CSproj file. I've probably seen that before if you're using XUnit. So we need to make a few changes to that. The first change we need to make is to change the SDK type to microsoft.net.sdk.razor, and that just enables the Blazor compiler to come in and do its stuff. And we want that because we want to write our test in Razor files. That gives us some advantages I'll come back to later. And then you obviously need to add a package reference to bUnit. And that's just it. So this is basically what it is. But you might also be asking, why is it even necessary? And originally, when I started building bUnit, I was sort of in the early days of Blazor. I was trying to just build a component library like, I guess, everybody else who was experimenting at that time. And like I said, I don't really like writing production code at a certain level. I want to have some test for it, and I couldn't really figure out to test it. And it turns out there is some things you need to do to really simulate that production environment, right? That a Blazor component exists in. So one of the things is that, components, they do have lifecycle methods. And during a test, you need to make sure that those lifecycle methods are called and used in the same way that the Blazor runtime would do it. Similarly, parameters, services, and other things like that, they need to be passed into the Blazor component in the same way that the Blazor runtime does it at the right time. And there's event handlers. We need to trigger those in the same way that the Blazor runtime does it. I guess you're seeing a pattern here. But I think most importantly is Blazor components actually doesn't know how to produce markup themselves. What they are a sort of a conceptual abstract representation of what the markup is that you want. And then we have something called the browser render, if it's you rendering out to a browser, that will come by and take that representation and turn that into markup. And all of that is basically what bUnit helps you with. So that's why we need it. Now, the hello world of bUnit testing, looks a little bit like this. So this is the counter component. I assume most of you know what that is, but if you've forgotten how it works, it is basically a button you can click, and there's a counter that increments by 1. So if we want to write a test for that, we do something like this. Well, we start by creating a Razor file, and let's call it countertest.razor, and we add a code block, and in that code block, we add our, I'm going to use XUnit in this demo, but we add an XUnit test. And the XUnit test is called counter should increment when clicked. So first, in that test, we need something called a test context. It's a bUnit thing. It's the thing that allows us to sort of drive a Blazor component through its lifecycle and interrogate and see what is happening under the hood. Now, once we have that, we can call the render method, and we can pass in the counter component, and out of that we get something called a render fragment, which is that thing, that container that represents the render component plus the DOM tree that has been built and so on and so forth, and allows us to interact and assert and do things with the component. And you might notice I use the abbreviation CUT. It stands for component under test. So if you're familiar with other XUnit terminology, you might have heard the term system under test. So this is my little take on that. So component under test for CUT. And once we have the CUT, we can go ahead and use the find method that takes a CSS selector, and that will give us out the button that we want to attempt to click. And once we have that, we can use the event trigger method click. It should be quite obvious what's going on here. And once we click that, well, now we need to assert something. And what we would like to assert is we go into the DOM tree again after we've done the click and find the paragraph element. And that paragraph element, we can use the bUnit's assertion method markup matches on and say, well, now I expect the paragraph element to look like this. It should have current count :1 in there. So that is sort of the hello world Blazor test, if you like, a bUnit test. And one thing you might be noticing, if this is first time you're looking at something like this, is that we have sort of this weird markup directly in our C# code, and it's pretty wild that we can this, but this is actually supported in the Razor language, and so basically we're able to start out in markup mode, escape into code mode by using the code block, but inside code mode we can actually escape back to markup mode by just adding that @ sign you see in front, and that gives us the ability to define our component under test in markup like we see here, and it also gives us the ability to define maybe expected HTML like we see here, with highlighting, with IntelliSense, with autocomplete, and all that help we usually expect to get from the editor, so that's super nice. Now, running the unit test, because it's just an XUnit test, it's still just an XUnit test, even though we have a bunch of bUnit stuff in there, we can run it from Visual Studio, we can run it from the command line, or wherever you can run your unit tests. So in this case, I'm just going to run it with .NET Test and a little bit extra source to give us a better output. And when we do that, well, we get the output we see from running .NET Test. That also means it just works on CI like anything. There's nothing special going on here, nothing magical. Okay? So now we know how we can go about verifying stuff and how we can build our test and how we can get started. But now we need to sort of answer the question, well, what do I want to verify? What do I want to ensure about my Blazor component? And you could decide to do what we did here, where we say, well, we want to assert a certain part of the markup looks like this, or you can more focus on the functionality, like what happens when I interact with that. And there wasn't a lot of functionality. Well, there was pretty printing of in our data table component. That was, we're going to print out automatically print out a table for you, but there's not we didn't have any buttons you can click and stuff like that. So I'm going to take another example to sort of show that off now. I don't know how many of you know the Blazing Pizza workshop. You can see the URLs down here at the bottom of the slide on screen. It's a good workshop if you want to get started with Blazor or just learn all the small corners on Blazor. Actually, it takes you through most of the details that are there. I also have a version of the workshop, the links next to it, that includes tests. So if you want to see how I went about working through that workshop and creating tests in every step, then that's also an option for you. But the Blazing Pizza workshop is a workshop where you create a web application that allows you to order pizzas. And the Configure Pizza dialog is a way where you've chosen to order pizza and you are able to maybe add extra toppings. So if you want to write a test for this functionality, well, how could that look? So, well, first we need a test class, obviously, and we can call that selecting topping from dropdown, add it to the pizza. And next we need a test context, and we need a new pizza that we can, that's going to be our state container as well, and we pass that pizza to our configure pizza dialog. It might look a bit like we're just passing in a string to the configure pizza dialog, but that variable, it's actually just a reference to the variable on the line above where we knew about pizza. Now we need to go ahead and find that dropdown, and we can use the change method on that dropdown to change the selection to the number 1 element in the dropdown. And after we've done that, well, our assertion would be that, well, in this case, it's going to keep it simple. So we just say, well, now the pizza's toppings collection should not be empty anymore. So the interesting part about this test is that we have very limited dependence or coupling to the actual markup that was generated by the configure pizza dialog. We don't do any assertions on the markup really. Well, we do need to know that there is a select element that lies at a specific position that we can use a CSS selector to get at, and we can trigger something, an event handler on that will do something. But the idea here is we want to be able to create tests that don't break if we do refactorings of the markup that represents the configure pizza dialog, for example. As long as we only want our test to break if the business rule, if the business conditions that we are trying to verify here changes. So this is an approach to creating stable and maintainable tests where you only sort of make sure you have them targeted at what you are actually wanting to assert on, and not try to make them resilient against breaking when they shouldn't. Okay, but obviously sometimes it can be very, very valuable to verify markup. It could be, for example, you have a designer in your company, or maybe you are the designer, and you've decided that a certain piece of markup has to go together with a certain piece of CSS, right? And if the markup is not right, the look and feel of the app or the component you've written isn't going to be right. It could be that you're building a third-party component library somebody else is using, and you want to make sure you don't break them if you accidentally change significant things about your component. So doing just markup comparison has historically been quite hard, but with bUnit we are able to do that semantically. And that means that a semantic comparison means that two markup snippets are equal if they render and behave the same in a web browser. That's really ultimately what matters, right? The opposite is the classical thing where you compare two strings to each other using just, assert equals or string equals. And obviously, a insignificant change to white space, indentation, or stuff like that, which doesn't matter in the browser, well, they're going to break your test. So we don't want that. So consider this dialog button component we have up here, and this straightforward test of that. So we're just asserting that the markup is right. And we use markup matches. And markup matches is the assertion method in bUnit that allows you to get that semantic comparison logic built in. So if I, for example, go and do Control KD in my dialog buttons component, well, this test will still pass because they will still look, the two snippets of markup will still look the same in the browser, right? So that's what we want. We want to be able to do insignificant changes to our components on our test without breaking our test. We don't want unstable test. Another thing we can do is, well, order of attribute doesn't matter, so tests still pass. We can even go ahead and, another example would be changing order of classes in a class attribute. Still, the test would pass because they are still semantically the same. Now, there can be more advanced scenarios, for example, where you have attributes that have generated content. Maybe that content changes every time. Maybe it's like an ID counter or a GUID or something like that. Well, the semantic comparer in bUnit has an ability where you can pass it various semantic comparer modifiers. And in this case, we're saying, well, instead of doing a string comparison of the ID attribute, just apply this regex instead and use that to check if it still matches. So again, it's about creating stable environment for your tests so they don't break when they don't have to. Sometimes we also know that maybe the button belongs, well, not in this case, but in case we wanted to ignore the button, for example, because it belongs to a different component that isn't really the component of the test, well, we can just say there's going to be something in the not componentry, but in the DOM tree that is not really relevant for this test, so just ignore that. So again, allows us to create stable tests that we can trust and keep around. And about that, creating maintainable tests. So these ideas are actually quite generally applicable also to regular unit tests. So let's have a look. So I generally like to avoid duplicated code in my test classes. That also means like test components as we've seen today. I don't necessarily mind having duplication between test classes because in general, different test classes will deal with different system on a test or component on the test, and you would want to be able to refactor those individually and not have them break together, right? Have dependencies between them. So another thing I like to do is move common arrange code or into constructors or setup methods. If you're using NUnit, you will have a setup method instead of using the constructor like we do in XUnit, so that we don't have duplicated stuff. Move that away and package it into something. If you need to create test data, or you have a more complex setup for your component on the test or system on the test, maybe look to creational patterns, or you look to testing libraries that can help you with, for example, Autofix. I use that quite a bit, or Bogus is another good library for creating test data that is not really particular to the specific test, but is needed maybe to make a test pass through its whatever it's going to do. I also, and this is specific to bUnit, but only verify markup that belongs to the component you're actually testing. So that is where you might say, well, the rest of this DOM tree here, just ignore that bit. It's not relevant here. Some of you might have heard this, like stick to one logical assertion per test. And I don't mean one assert statement, like assert equals something, something. I mean one logical, like you can have multiple assertion statements, but they should all center around one thing that the test is about to verify. So don't put too much into each test, rather duplicate the test so you have more conciseness about why a test is failing. And one thing I also really like to do is to, if I have sort of a pattern of assertions that I'm repeating from test to test, but with maybe different input, create helper methods, create assertion methods, custom assertion methods that sort of encapsulate that logic, and maybe give those assertion methods names that represent the domain language you're building software in. So again, that will make your test much easier to read because you will have the language you're expecting. It won't be the generic assertion methods you're seeing. Now, how do we apply this to testing our data table component? Well, the first thing we can do is create a data table test.razor file and have that inherit from test context. So test context was the bUnit thing, and by having our test component inherit from that, it becomes the test context, which means all the methods we need to do our work will live on our Razor test class, which means they're readily available, and we don't have to new up the test context in each and every test. So the first test we could create would be just like a hello world test. Just test the minimal thing that should sort of matter for the data table component, and that is that it renders the sort of outer structure correctly, which means a table and a header and a body, right? So we just render the data table component, and we don't even pass in items. We just say that the type you're going to be working with is going to be object, and since object doesn't have any public properties, it's going to be quite simple, right? So our assertion will be, well, we expect to have this table. We expect to have a table, a T header, but we're going to ignore the children because that's part of the data table header components domain. And we're going to have a T body. It's going to be empty because there's no items, and we're going to have a closing element for a table. So that is sort of the simple test we have just to verify that the data table does build the right markup for us. Now, the next we would want to do is to test how the data table uses the data table header component and that it does the right thing, puts it in the right place, because that's important, right? So again, we have the same render command, but this time we will go in and you will, when you think about it, there's sort of two trees that are outcome of rendering a Blazor component. There's the DOM tree, the markup that produced, that's a tree in itself, and then we have the component tree on the other side that contains the hierarchy of components that has been built. And in this case, we're going to go into the component tree and say, find me the component, the child component of type data table header, and return that to me. And that allows me to now go and say, well, I expect all the content of the data table header component to be the child nodes of the T-head element that the data table component has created. So this sort of ensures that the composition between the data table and the data table header is correct, without tying my data table test to whatever the data table header decides to do. Now, we need to do the same for the data table row, and we can take a slightly different approach here to try something else. To have something meaningful to verify against, this time we have to pass in real data to our data table. Otherwise, there's not going to be any data table rows to look at. So we're going to pass into movies in this case, and we're going to render our component, the data table component, with those. And now we can use the find components plural again to go down in the component tree and pull out the data table row components that was created by the data table component. And once we have those, we can go into those and say, give me the items, the movies that you were passed when you were called being rendered. It's a bit convoluted, I admit, but yeah. So the end result is that we have a list of movies that were passed to each data table row in the same order they were passed to them. And now our assertion is, well, the movies we found in our rows, in our component tree, they should match the original movies that we passed into the data table. So this is sort of a way, again, to verify that the data table is using its child components correctly without really tying us in and for example, from a data table test, look and see that we had the right amount of TR elements and look at the individual content of each TR element. Now, that belongs in the data table row test, so let's have a look at that. I'm going to skip the data table header test because it's going to be very much the same as what we see here. So the first test would be, well, in case we just tell Blazor to render a data table row without any data, well, we just expect it to do the minimal thing, which is to render out a TR, and you can even argue maybe it shouldn't even do that, but I guess in this case I decided that it should. Now, a more interesting test is where we pass a single item to it, and then here we can say, well, now, because this is your responsibility, this is your domain, so this is the markup you should be producing. So if we sort of go back and take a step back and look what did we actually do here with these couple of tests. Well, because we split our data table component into multiple subcomponents that we can evolve and work on individually, well, we have now been able to verify the component markup in isolation for each of the components, and that means we have simpler tests, we also have simpler components. Also, we did write some tests that verify the composition, how these components are used together, combined together, in that sort of nice composability that we have with Blazor. Okay? So sometimes you want to do a little bit more. You want to completely remove a child component. So if we have a simple example here with a foo that has a bar as a child component, sometimes you want to just take that child component completely out of the equation. Now, why would you do that? Maybe if you can answer yes to this question, should changing bar break foo in any way, or should rather break foo's tests? Well, probably not, and there might be reasons why you want to not have bar there then. It could also be that bar is a third-party component, and third-party components shouldn't be your responsibility to test. Supposedly, the third-party component vendor has written their set of bUnit tests, I hope, and sort of done their due diligence and ensured that the components work as intended. And also, if they change small things, maybe like pop-ternal things in there, it shouldn't really break your test because it's, at the end of the day, it's not your responsibility. So what we can is we can substitute bar with something else. We can't remove it from the component tree because the component tree is statically compiled at compile time, right? But we can substitute it with something else. So Blazor is rather flexible with that, and it's kind of nice. So let's look at the rules for substituting one component with something else. And the first rule is that the substitute must be a Blazor component. And that means at the very minimal, it has to inherit from iComponent, which is the minimal thing that needs that sort of specifies that this is a Blazor component. Now, another thing it must have or must be, it must have the same parameters that the thing it's substituting, that the original component has. And this is a really nice sort of fallback, is that we can also just have the component, our substitute, implement parameter that has that capture unmatched values in it. The point is Blazor just needs a way to take the parameters that pass to our bar component and have somewhere to put them. Otherwise, it's going to blow up and say, hey, there's something wrong here. Yeah. So, and that is a third rule that only really comes into play if you have one of those add-ref keywords on your components and are referencing the component in your component under test. So in this case, we're referencing bar in our foo component. And for that to really work, bar has to be, this bar substitute has to be a bar, because otherwise Blazor cannot assign at runtime whatever substitute component you have to the variable field bar. I don't know how many of you often use the add-ref keyword. I don't see that a lot in my Blazor apps, so it tends not to be a huge problem, but there is workarounds for this if we need that. But obviously we don't want to manually create new substitute components for every component we might want to replace during testing. So to make this a bit easier and approachable, bUnit comes with a stop component. And a stop component is something that looks like this. It has a signature called stop of T component, and T component is the component it's substituting. And it is a Blazor component, so the rule number 1 checks out there. It also has one of those capture all parameters, and it even makes that available to you. So if you want to assert against that, you want to assert that your stopped out component actually did receive the expected parameters, you can sort of make that composition verification that we talked about earlier. But it clearly isn't a T component. Like stop is not the original. So for the third rule, if you're using the addref keyword, we can't use the built-in stops. But again, for most cases, it's not a problem. Okay, so let's look at some code. So component factories is the properties on bUnit's test context that bUnit used to control how components are instantiated. If you don't add anything to that, it's just going to be the whatever component you have in your component tree originally. But in this case, we have a method called addStop that takes a generic parameter of the type of component you want to substitute out. And that's just basically that's what we need to do. And now we can go ahead and say render component. And now if we go and use the method called hasComponent, which just queries the component tree and asks, do you have this component in you? Well, if we ask for a bar, then you should get false back, and if we ask for stop of bar, well, then we get true back. Sometimes you also might want to have bar print out some markup, like the stop of bar, rather. You want that to put some markup into the DOM tree. There can be some reasons for that. Maybe it will make some assertions easier to write. And for that, we just have a sort of a render template kind of method here, where you actually the PS variable we have there on screen, it's actually the parameters that were passed to original bar. So you can even output some of the parameters that were passed to original bar out into the markup if you like that. But as you can see now we can assert that, well, the not bar markup in the h1 tag there is actually part of the foo component. Another thing you might want to do is stop out a whole set of components. Perhaps you want to stop out everything from a third-party vendor. And then instead of using the generic version of addStop, you use the non-generic version that takes a type predicate in, and you just say yes whenever you want to stop out a type, and no if you don't. So in this case, we're saying every type that lives in the namespace that starts with third-party library are going to be stopped out. Okay? And I don't know if any of you have built React apps before, but in React, in the testing world there, they have a concept of shallow rendering. And we can sort of emulate that a little bit. So shallow rendering means just render this foo component directly as it is, without any of the child components, no matter what they are. And we can fake that. This is like a poor man's shallow rendering, where we say, well, as long as the type is not equal to whatever I'm testing right now, my component on the test foo in this case, just stop it out. So that also works. Now, we still have that third rule that didn't really work for us with the stop. And this is where mocking comes in. So mocking components using third-party mocking libraries like NUnit or NSubstitute or something work surprisingly well. And it does this, and because mocks, they inherit from the mock component, that means that the third rule checks out. So if we have addref in our code and referencing something we want to stop out, we can actually do that. And the reason why we typically have an addref to a component we want to stop out is because we want to call methods on it, right? That's usually the primary reason why you use the addref keyword in the first place. So you would want to set up what happens when we call those methods on our component, and that's what we can do through mocking. Now, the reason why it works so well is because most Blazor components inherit from component base, and component base has all those nice lifecycle methods like uninitialized, on after render, and they are all virtual. So when a mocking framework sees virtual method, it just says, I'll take all of that, and basically, unless you tell me to do something with them, they're going to do nothing. So that means the component doesn't do anything really, because it's been neutered by the mocking framework. There is some exceptions though, and it's if you have a constructor in there, it can't prevent the constructor from running. It cannot prevent a dispose method from running unless it's virtual, of course. And if you have field initializers or property initializers, they're also going to run. But so we're sort of into corner cases here, and for most cases, it's probably going to work quite fine. Now, reusing mock instances is not allowed. So if you have multiple components you want to mock, like multiple bars in the same foo you want to mock, you have to create a mock for each of them. So Blazor doesn't allow the same instance of a component to exist multiple places in the component tree. That's basically what that rule means. Okay. So let's look at an example. So I'm going to use MOQ here. I'm not really a mock MOQ expert, but I think this is, I gathered that using that because that seems to be the most used mocking framework in the .NET community, so I thought that was a better chance for everybody to understand what's going on here. So basically, we're just creating a mock of the bar component, and we are adding that to our component factories by using the add method that takes a generic parameter, again, of the component we want to substitute out, and we pass in the instance of the substitute, in this case, the bar mock object. Now, if we go ahead and render the full component, well, we can see that if we go and ask find component, we use the find component again to go into the component tree and find the bar component. We do actually get one out, but when we go a bit deeper and look at the instance of that component, we will see that it is actually the same as the bar mock object. So we did actually substitute out with the mocked object. That's pretty cool. Now, if we do have multiple bars in a foo, well, what we can do is, I find something in the mock library called mock repository that allows us to set up common, rules for a mock, and then instead of using just passing in the concrete mock replacement, we can use the add method here that takes a factory that is called whenever bUnit sees a bar in the component tree. It will call this method and say, give me a replacement for a bar, a real bar for that matter, doesn't matter. And it will do that. And now if we go in and use the find components to find all the bars components in the component tree, well, here we have the outputs. And we can verify again that using the mock.get method to verify that the instances of the first bar and the second bar is actually mocked components. Okay, so that was quite a bit we went through. So let's just quickly sum up and what did we sort of get through today. So I think it's important to say that like the techniques here, it's a techniques you're probably already known and aware of from your regular C# code or from whatever code you write in your day job. But yeah, we talked about how we can take those concepts of cohesion, abstraction levels, and that thing about doing one thing well and apply those to Blazor components. And don't forget them just because it's easy to add more markup in there. I gave you an intro to bUnit and sort of told you what it is and how you can use it. And now we've went through a bunch of examples of how to actually write tests so that they become maintainable and how to split things up and make sure you test for the right things in the right types. And obviously, yeah, some mocking here at the end, that always is a fun tool to have in your toolbelt. So I'm going to say thank you very much for your attention. It's been fun here, and you have some of my contact information here. If you have any questions, or you can come up afterwards and say hi and ask your questions. I want to give a quick shout out to these two companies, Progress and Syncfusion. They have been sponsoring my work with bUnit for quite a while. And I want to encourage you to go home to your company, and if you are in a position where you can maybe help out some of the open source projects you might be using that are critical maybe to your projects, to your infrastructure, see if you can go and support them. As an open source developer myself, I can say that it makes a big difference. It might not be that you are actually paying them, the developers a full-time job. It might just be, candy money or extra coffee or something, but just the encouragement of getting a little bit of support from the community makes a big difference to open source development. So I highly encourage you to see if there's any way you can give a little bit back as well. So thank you very much and have a safe trip home.